Okay, on this video we are going to solve a Bernoulli differential equation. Okay, now the first thing to do is to get the shape of the line of the Bernoulli differential equation. Now, first of all, here you have an x. In the shape, you are supposed to have only the number 1. So what we are going to do is a fix. So we are going to divide by x in both sides. So what happens here is that you will get derivative y respect to x with the coefficient 1, which is required by the method, plus 1 over x y equal to this x squared over x, just 1x, and then y squared. As you can see here, you have the shape of the linear of the Bernoulli differential equation. So this is your p of x, and this is your q of x. Okay. Now, here, y squared. If you remember, the shape is derivative y respect to x plus p of x y equal to q of x y to the power of n. So here, the n happens to be just 2. So what is the variable change? The variable change is like this. W equal to y to the power of 1 minus n. 1 minus 2, which is just y to the power minus 1. Okay, so that is the variable change. So derivative of w respect to x, if you take the derivative of this, is going to be minus 1. The minus 1 goes down, and then y to the power minus 2, and then the derivative of y respect to x if you use the change rule. Okay, so what you have to do according to the method in the previous video is that you are going to multiply this times your differential equation, your whole differential equation, not this one, this one. Okay? So if you do the multiplication, you are going to get minus 1 y to the power minus 2, derivative y respect to x, plus, minus because this is minus 1 over x, and be careful with the y. So this is y to the power minus 2, and here you have power 1. So this is y to the power minus 1. And then equal to minus x here, y minus because you have a minus here, y to the power of minus 2 times the y to the power of 2 is y to the power of 0. Okay, now here comes the magic. The magic is this one. Here happens to be the derivative of w respect to x, and the y to the power minus 1 happens to be the w. Okay, so if you do the variable change, so this becomes derivative of w respect to x minus 1 over x and w equal to minus x. So now it is a linear differential equation. Alright? Now we can solve it, and let's solve it. And the method says that you have to calculate the integrand factor. The integrand factor is with this p of x. Now, so let's calculate the integrand factor. I'm going to use mu of x. In the past I used w of x, but I cannot repeat the letters because I already have a w here. So it's going to be the exponential of the integral of p of x, differential of x. So this is going to be exponential of the minus integral of 1 over x differential of x. Now, the minus goes in the p of x, so don't forget the minus. So this is going to be exponential of the minus natural ln of x. So this is going to be x to the power minus 1 if you pass the minus to the power, and then cancel the exponential and the natural ln. So what you should do with this, then you will multiply this times the differential equation. So it's going to be x to the power minus 1 derivative of w respect to x minus this 1 over x is also x to the power minus 1, so it's going to be x to the power minus 2 w equal to, now this times this x is just minus 1 x to the power of 0. And then here comes the dead step, el paso de la muerte. The dead step is here. So you are going to replace this by what? Derivative respect to x of two things. What are those two things? This and this without the derivative. So it's going to be x to the power minus 1 times w equal to minus 1. Alright? Don't forget the dead step. Dead step. Now, to check if you are correct, you can develop the derivative of this multiplication. So if you develop this, it's going to be the first times the derivative of w respect to x, which is already here. And then times w, which is here, times the derivative of this. The minus 1 goes down, and then x to the power minus 2. So you have it there. Okay, so now this is a variable separable differential equation. How? Like this. The differential of x to the power minus 1 times w equal to minus differential of x. So this is very easy problem, because you apply integrals on both sides, and the integrals and differentials, they cancel. Okay, so what you have here is x to the power minus 1 times w equal to minus x, and don't forget the constant. Okay, this x to the power minus 1 is equal to 1 over x. 1 over x, so the x goes as a multiplication, so w is equal to minus x squared plus cx. Okay, now is that the solution? Yes, it is the solution. But is this the solution for this differential equation? And we are really looking for the solution of this differential equation. So this comes what I said in the previous video. Don't forget to bring back the variable change. So bring back the variable change is w. What is the value of w? W is equal to y to the power minus 1. So this is equal to y to the power minus 1. Which means that this expression is equal to 1 over y equal to cx minus x squared. Okay, so y, if we flip this fraction, we are going to get y equal to 1 over cx minus x squared. And here you have your explicit solution. Okay, so here we are not given an initial condition, so that means that the constant we should not calculate it, because we are not given the initial condition, and that's it. This is your solution. Okay, so with this we finish this method of Bernoulli differential equation. Be careful with the variable change, and don't forget to bring back the variable change. Okay, now with this we have finished all the methods to solve differential equations. So on the next video, what we are going to cover is applications. All right, so that is the most difficult part of the first unit. See you in the next video.